Hi everyone, this is AP Stats notes on 4.3, and this is really just like a wrap-up day, so we're going to go through this really fast. One of the things that we want to make sure that you remember is what's the difference between randomly selected and randomly assigned, and what do we get from those? So remember that if we are randomly selecting them, right? If we're randomly selecting them, then we can go ahead and we can talk about things about that population. Okay, so anytime we pick somebody out of a group in the neighborhood, then we can say it applies to everybody in the neighborhood. If we don't do that, then we can only apply it to those that we sampled. Okay, so we can't do the population, we can only do those that we sampled. So if again, I ask a few people or do an experiment for a few people in the neighborhood, then it only applies to those few people in the neighborhood, right? All right, on the other side though, we have, were they randomly assigned to groups? And if they were randomly assigned to groups, let's do this version instead. And if they're randomly assigned to groups, then we get to do cause and effect. So then we get to do cause and effect and say that this thing actually causes the other thing to happen. Okay. If we don't randomly assign them to groups, then we can't do cause and effect. All right. So keeping that in mind. All right. Next part, randomly selected are the only group that could lead to inference about the population. And inference is just another name for like a claim or a mathematical, like logical reasoning. Randomly assigned to groups, so this is randomly selected. Okay, randomly assigned to groups are the only groups that could lead to causation or cause and effect. So of course, in a perfect world, we'd have both, randomly selected from the population and randomly assigned to groups. Randomly selected from the population, we did at the very beginning when we were doing observational studies of how do we get a good sample. Randomly assigned to groups is more the idea of an experiment of trying to make sure that this thing causes that thing. So, well-designed observational studies well-designed experiments randomly assign individuals into treatment groups. So this is experiments and observational studies don't randomly assign them to groups, but we do use random sampling in that process. All right. Okay, next part is some examples about what can we conclude. So many students insist that they study better when listening to music. Ask them whether or not they study with music on and divide them into two groups based on the answer to this question. So the first thing is always, did I randomly select from a population? So random selection? No. How about random assignment? Did we randomly assign them to different groups? No, based on whether they liked it or not, right? So that means that random selection, we cannot go to population. And without random assignment, we cannot do cause and effect. Causation, all right? Randomly select students from your school to participate in a study and divide them into two groups as in design one. Okay, so do we have random selection? Does it sound like it? Yeah, they were randomly selected, yes. So what does that mean? It means I can apply to students at your school. And that's instead of just the students that you sampled, okay? And then random assignment, did they randomly assign them to two different treatment groups? And it says just divide them in the same way that you did there, so that's no causation. So you can see we can get every basic combination here where you're just looking through each one and trying to see how did we take them from the population and how did we assign them? Did we randomly select? Did we randomly assign? All right, so get all the students in your AP Stats class to participate in a study, randomly assign half of them to listen to music, while studying for the entire semester and have the remaining half abstain from listening to music for the entire semester. So do we have random selection in this one? No, we went and got all those, so we can't apply it. So not applied to all students at a school. So the only thing I can apply it to is those people who participated, right? And then do we have random assignment? We randomly assign, so we do. So now we can prove cause and effect. So yes for cause. So we could still show that listening to music would be helpful or not listening to music would be helpful, right? And then the last one, select a random sample of students from your school to participate, randomly assign half. There we go, we've got both. So random selection, we've got yes, so we can apply it to all students at the school. And random assignment, we've got that, so we can prove cause and effect. All right, next part, establishing causation. A well-designed experiment tells us that the changes in the explanatory variable cause the changes in the response variable, so that EV leads to RV, okay? Lack of realism can limit our ability to apply conclusions. So this would be something like where we try to simulate something, but we do such a bad job of it that everybody knows we're faking something. So it should seem realistic, right? I'm going to skip over this one, but it says speculate 2 reasons that the study may not have students choosing the healthier menu options. So you can think about this one of where is the lack of realism here? If you're looking at 2 different menus for healthier choices, is it really realistic, or do you think they would catch on that maybe we're checking them out for realistic choices or healthier choices, and maybe they'll pick the healthier options anyway? And in some cases, it isn't practical or ethical, right? So we're not going to do an experiment that kills somebody. We're not going to check into whether texting while driving is going to increase accidents or deaths. We're not going to actually experiment on those. We're not going to go and check and see if people who go to church regularly help people live longer. We're not going to mess with randomly assigning people to get to go to the church or not go to church. That's not fair to them. And does things like smoking cause cancer? So again, we're not going to force people to smoke who don't want to, just to see if we get a good experiment. So you got to do things that make sense where you're not hurting somebody. It's sometimes possible to build strong cases for cause in the absence of experiments. And this is really not so much for the AP course, but just in general, there is a way we can get to causation, but for the course, you're going to stick to those main things about random selection, random assignment. There are some times where the courts will consider causation if the association is strong, if it's consistent, if larger variables, values of EVs are associated with stronger responses, the alleged cause precedes the effect in time, and it's plausible. Again, for our course, we're going to mainly focus on that random selection and random assignment. Okay? Complex issues of data ethics arise when we collect data from people. Here are some basic standards about data ethics that must be obeyed. So again, this is just common sense types of stuff, right? So first one is all planned studies must be reviewed in advance by an institutional review board. Right? You're not just going to go and do an experiment because it sounds like a good idea. You're going to put it in front of experts that say, yes, that seems like a safe thing or an okay thing to do. All students who are subject in a study must give their informed consent. They have to understand what they're putting themselves, their bodies into an experiment before we can start collecting data. And all individual data must be kept confidential. Only summaries for groups of subjects may be made public. Now, confidential means I might still know who the person is, but I'm not going to publish individual people results. It's almost the difference between me posting our average class score versus posting the list of everybody's score and then showing the average at the bottom, right? So confidential versus anonymous. So in anonymous, nobody knows who you are. There's no way to track it back to you. So these are usually done with some kind of number, like some kind of customer number or patient number. When you donate blood, I think they give you a number to call with your number of your blood so that if you want to say later, don't use my blood because it's bad for whatever reason, That's an anonymous one. They don't have your name attached to that. They just have the number to trace it back to your donation to make sure it gets pulled before it gets processed to help somebody else, right? So confidential survey, the person actually knows. So somebody knows. Person is known somewhere. It's just not published. It's just not published. Okay, so they asked, we have a regional water agency calls a random sampling of customers and obtains answers to the questions relating to the water use at the household. The results of the survey are published with statistical summaries. So the question is, if the water company is calling us, do you think they are keeping track of who we are, or do you think they're just randomly collecting data? I'm going to go with, I think that they are probably doing something confidential and that they're calling us so that they probably know who we are. In example 4, a student healthcare center on a college campus is offering free AIDS screening. Students may submit either their name or a randomly assigned number on the test. The student is given the phone number to call to receive the results. So this one could be either or, depending on which one they use. Do they use their name or do they use the randomly assigned number? So if they use the randomly assigned, or if they use their name, then it's confidential. And if they use the number, then it's anonymous. All right, so this front part, this big table at the beginning is called scope of inference. And it's basically what we can conclude in observational studies and in experiments. You should be familiar with what do you get when you randomly select, what do you get when you randomly assign. That's it. Bye, guys.